Hai, Assalamualaikum warahmatullahi ta'ala wabarakatuh. Now we are going to look at chapter 4, that is frequency response analysis and design technique. This chapter presents the design of feedback control system through gain adjustment and compensation networks from another perspective, that of frequency response. The results of frequency response compensation technique are not new, not different from the result of a root locus technique. In this chapter, you will learn the following: the concept of frequency response, how to plot frequency response, how to use frequency response to analyze stability, and how to use frequency response to design the gain to meet stability specifications. Before we go further, we need to understand the concept of frequency response. In the steady state, the sinusoidal inputs to a linear system produces a sinusoidal response with the same frequency. Consider a linear system with a sinusoidal input. So this is the equation of the sinusoidal input, where Mi is the amplitude, omega I is the frequency of the sinusoidal input, and theta I is the phase angle. When it goes into a linear system, it will produce the same sinusoidal output with the same frequency of the input. However, the magnitude and phase angle changes. To relate the frequency response with electrical system, we consider an electrical system as a convenient representation of sinusoids. The input source of the electrical system, V in T, is equals to Mi cos omega t plus theta I. This is the amplitude of the voltage, while omega is the frequency of the voltage and Phi is the phase angle of the voltage input. This electrical system will produce an output voltage which is equals to M out cos omega t plus phi angle. The sinusoidal signal can also be represented as a complex number called phases. This is the normal sinusoids, and we represent it in a complex number called phases. So the overall system can now be represented in complex numbers, that is, phases. Even though the output frequency is similar with the input in this response, the amplitude and phase angle are different from the input. This difference is called as function of frequency. So if we look at the input signal, this graph over here represents the input, the sinusoid input. So Mi is the amplitude of the sinusoidal signal, while Phi is the phase angle of the sinusoidal signal. The same sinusoidal signal is produced at the output response with the same frequency. We can see the frequency omega is similar to the frequency omega at the input. And the amplitude changes to mi multiplied with m, while the phase angle changes to phi plus phi. So that m omega is the magnitude frequency response, while phi omega is the phase frequency response, and the combination of m omega and phase omega or phi omega is called the frequency response. Now we have understand the concept of frequency response.